This video is about a substitution, u substitution. And so what it really is the reverse of chain rule. We're finding the antiderivative of a function that was created using chain rule. So how it works is this. We take the inside, and whatever that is, we call that now u, because we don't want to distribute that 3 out and go 2x plus 7 times 2x plus 7 times 2x plus 7. It's too big, too much work. So if we end up just calling it 2x plus 7, then we end up with this. But now it's a u, not an x, so we have to get rid of our dx as well and change it into du. So if we come over to this u and we take the derivative with respect to x, we end up with this. And then if I cross multiply it, I end up with this. And so now I can solve for my dx, which gives me du over 2. Replacing that, I end up with this. So now you can see there's no more x. What we've done is taking something that was difficult to take the integral of without expanding and converting it into something that is much simpler now in terms of u. So we bring that half in front and we end up with this. And you know the integral of u cubed, that's just 1/4 u to the 4th. And we have a half. Remember, we got to put plus c. So this would become 1/8 u to the 4th plus c. And then you look back at the problem and you go, wait, we started with an x. That can't be correct. That's right, you have to plug it back in. So whatever we replace the u with, we now put back in. So the whole idea is to take a function that is not nice, replace it with another letter that is nice, complete the integral, and then put the non-nice stuff back in. And so if we now take the derivative of this, you would get 4/8, which is a half, 2x plus 7 cubed, and then we have to multiply by the derivative of the inside, and that would become 2. And so by taking the 2x plus 7 here, and we make that our u, and we take the derivative and then solving for dx, you see we're getting the opposite here. So what we're plugging in here is that number that would have canceled this. It's working in reverse. So you see this half being here, that when you take the derivative, that becomes 2. The 2 and the half cancel, because that's what we knew would have been formed to begin with. So finishing our check, they cancel, and we end up with 2x plus 7. Checks out perfectly. So now we can erase it, so we don't want that to be part of our answer, and there we go. So let's try it again. So now what's the inside of this one? It's the x squared plus 1. So we make that our u. And so our du would be 2x. And then a quick trick now is you notice that we get du dx each time, and then we're just going to bring the dx over. So when you do this, just write du, and on the other side write dx, and it just saves you a little time. Now we can say dx equals du over 2x. Plugging that in, we get 2x, u to the 4th, and then dx is du over 2x. So you can see the chain rule had already been applied here, and so we had x squared, its derivative is 2x. So it's just sitting there waiting for us to cancel it away. So now we have u to the 4th du integral. We take our integral, so it's 1/5 u to the 5th plus c. Converting it back to our x. There we have it. Then again, we do a quick check. So bringing down the 5, that would cancel, giving us x squared plus 1 to the 4th, and then derivative of the inside is 2x. Constant disappears, checks out perfectly, we erase it, and circle our answer because we now know it's correct. All right, this also works with radicals. So if you see a radical, remember this is also just another way of writing to the 1/2. So it's still in a parenthesis. So our u is 7t plus 5. So our du would equal to 7. And again, this is a t now. So instead of writing dx, I write dt. We solve for dt to replace it. So now we can say, well, that's u, because that's 7t plus 5. And our dt is du over 7. So it's 1/7 u to the half du. And then we add 1, flip it, put the 1/7 in front, and that gives us 2 over 21. And there you have it. So again, we should check this. So 3/2 comes down, so we get 2 over 21 times 3 over 2, 70 plus 5 to the 1/2, and then derivative of the inside is 7. Now everything on the outside should now cancel. So the 2 cancels the 2, the 3 and the 7 make 21, which cancels. Everything checks out to give us the square root of 70 plus 5. So it checks perfectly. And there you have it. So with u substitution, all we're doing is taking the inside of our problem, of our function, whatever's there, inside of our grouping, writing it as u, creating the other one for it. So if we have a u, we need a du, replacing the dt or the dx, simplifying, taking the integral and plugging it back in. You should get very quick at this.